So in the last video we saw what gears were and what gear trains are. So in this video we will be seeing some important terms related to gears and gear trains. See, this is the most important video of this entire series, because if you understand these important terms, only then will you be able to solve the numericals. So the first important term that we will be looking at is module. So what is a module? A module is defined as the ratio of the pitch circle diameter of a gear to the number of teeth on the gear. What do I mean by this? For example, see, look at this. Okay, here you can see an actual gear. This gray colored one is your actual gear, and here is another gear which I have just shown with its outline, blue colored outline. So pitch circle diameter, see this 100 mm what you are seeing is the pitch circle diameter of both the gears. If you will see that this is almost at the center of these two, see this is the top face of the gear, this is the bottom face of the gear, this is almost at the center point of these two. This is your pitch circle. Here also see, this is the top face, this is the bottom face. It is coming at the almost center of the top face and the bottom face. So this is defined as the pitch circle diameter of any gear. It is the imaginary circle which can be used to replace the gear. A pitch circle diameter is an imaginary circle. For example, instead of gears, if we want to use discs, so what should be the diameter of the discs used? Well, the diameter of the discs used will be your pitch circle diameter. So here we can see two gears which have the same pitch circle diameter. Both this actual gray one and this outer one, this blue colored gear, both have the same pitch circle diameter. It is 100 mm. But what is the difference? The difference is module. The gray one has a module of 5 and the blue one has a module of 2. So what was the definition of module? Module is pitch circle diameter divided by number of teeth. See, for example, both have a pitch circle diameter of 100. I am saying the gray one has module equal to 5. So if we calculate the number of teeth on the gray one, you will find that the number of teeth is 20. And if you count these blue gear teeth, you will find that these blue gear teeth are 50. So what was the formula for module? Module is PCD upon number of teeth. So in case of gray, as there are 20 teeth, the PCD of 100 mm divided by 20 gives me 5. 100 mm divided by 20 teeth gives me module equal to 5. And similarly for this blue gear has how many teeth? I said 50 teeth. So 100 mm divided by 50 gives you a module of 2. Thus, what is module? Module is basically, it tells us how close together the gear teeth are to each other. The bigger the module, the farther the gear teeth are from each other. See, for example, for module 2, the gear teeth are very close to each other. But for module 5, the gear teeth are very far away from each other. So module is basically a measure of how much the gear teeth are close to each other. So module is measured in millimeter, because pitch circle diameter is always measured in millimeter and the number of teeth is just a count. Hence, pitch circle diameter divided by number of teeth gives you a unit of mm. Generally, now here you can see, this has a module of 1.5, this has a module of 2, this is all in mm. Okay, now imagine you have to mesh two gears. You have one gear and you have another gear. You have to mesh these two gears together. If you use a gear of 1.5 module and if you use another gear of 3 module, these two teeth will not be able to mesh with each other, because these teeth, see for example over here, if you take one gear of module equal to 5 and you take one gear of module equal to 2, see here is your one gear and here is your another gear. These two gears will never be able to mesh with each other. See, these teeth will not be able to fit into these teeth. So whenever you want to transmit power from one gear to another gear, the gears must have the same module. Remember this, whenever there are two gears meshing with each other, they must have the same module. A module of say 0.1, 0.2 up and down will be okay. Okay, that is little bit approximation, but such a big difference, module 2 and module 5, these gears will never be able to interfere, these gears will not be able to transmit power to each other because the teeth will not be able to mesh with each other. That is why whenever we want to mesh two gears, we always mesh two gears of the same module. So please remember this definition. Module is pitch circle diameter divided by number of teeth, and the unit of module is millimeter. The next term that we will be seeing will be velocity ratio. First, let us look at the definition of velocity ratio. See, velocity ratio is defined as the angular velocity of the driven shaft to the angular velocity of the driver shaft. What do I mean by driven and driver? See, as I told you in the previous video also, whenever you use a gear train, there will be one gear which will be connected to the motor or to the engine, which is rotating automatically, and this rotational motion is transmitted to the other gear. The velocity of the driven gear, how fast the driven gear is rotating, divided by the velocity ratio of the driving gear, is known as your velocity ratio. For example, we can see this video to see what a velocity ratio is. See, for example, if this is your driving gear and this is your driven gear. So see, this is rotating at a very low RPM and this is rotating at very high RPM. Thus, it will have a very high velocity ratio. So this is what velocity ratio is. Velocity ratio is the ratio between velocity of driven gear and velocity of driving gear. Now that we know the velocity ratio, we will also have to find out a very important relationship between the angular velocity and the number of teeth on a gear. To understand this, let us look at this diagram. Okay, we will look it over here. See, this point A. This point A is common to both the gears. This point A is on gear 1 also and it is on gear 2 also. We know what is the velocity of a point on a circle. We know it is given by V is equal to R omega. See, so this point is on gear A also and it is on gear B also. So velocity of this point A is what? Radius of gear A into angular velocity of gear A, and it is equal to radius of gear B into angular velocity of gear B. So this can be rearranged as RA upon RB is equal to omega B upon omega A. Just rearranging this. RA upon RB is omega B upon omega A. So omega B, angular velocity of B. What is the formula for angular velocity? 2 pi n upon 60. So writing that formula over here, 2 pi n upon 60. So for B it will be NB, for NA it will be NA. 2 pi upon 60 is common in numerator and denominator, so it will cancel off. So we are left with what? RA upon RB is equal to NB upon NA. Now RA and RB are radius, so multiplying it by 2. So multiplying RA by 2 and multiplying RB by 2. So it is 2 over here, 2 over here. It doesn't matter, it is going to cancel out only. Multiplying both numerator and denominator by 2 makes no difference. So RA and RB, when multiplying it by 2, radius gets converted into diameter. So diameter of A upon diameter of B is equal to RPM of B upon RPM of A. Now see, we just saw this formula for the module. Module is what? Pitch circle diameter divided by number of teeth. So using that pitch circle diameter, so module is what? Module is equal to pitch circle diameter divided by number of teeth. So taking this number of teeth over here, we get diameter is equal to module into number of teeth. So rather than writing diameter A and diameter B, we can write module into number of teeth on A divided by module into number of teeth on B is equal to NB upon NA. Just now I told you that the module of intersecting gears must always be same. If the module is different, the gears will not mesh with each other. There will be interference. So this module in both these cases is same. So it can be cancelled out. So what are we left with? T of A upon T of B is equal to NB upon NA. So always remember this equation. This equation is very important. What is it? Velocity ratio is velocity of driven divided by velocity of driver is equal to what? Diameter of driver divided by diameter of driven, which is equal to number of teeth on the driver divided by number of teeth on the driven. So this is the second formula that you have to remember. This was the first formula and this is the second formula. Module is equal to PCD divided by number of teeth, and velocity ratio is velocity of driven upon velocity of driver, which is equal to diameter of driver upon diameter of driven, which is equal to number of teeth on driver divided by number of teeth on driven. And the last thing that we will be looking at is what are the different types of meshing. See, the meshing will result in a change in direction of the gears. First of all, we will see what are the two types of meshing. One is external meshing. See, for example, over here. See, in this case, the teeth of this gear are on the outside. See, this is my gear and the teeth are on the outside of the gear. Here also, this is my gear and the teeth are on the outside of the gear. So in this case, both the teeth are on the outside of the gear and these teeth are meshing with each other. Hence it is known as external meshing because both the teeth are on the outside of the gears. But see, in case of blue and red, in case of blue the gear teeth are on the outside, but in case of red the gear teeth are on the inside. See, it is towards the center. The gear teeth are towards the center of the gear. Hence it is known as internal meshing because that at least one teeth should be on the inner side and one teeth are on the outer side. So this kind of meshing where both the teeth are on the outside of the gears is known as external meshing. This type of meshing in which at least one gear has teeth on the inside is known as internal meshing. To further understand this, let us look at this video. See, in this video you can clearly see that as red is rotating in clockwise direction, green is rotating in anti-clockwise direction. Red is rotating in the clockwise direction and red is meshing with green and green is rotating in the anti-clockwise direction. From this video we can clearly state that whenever gears are externally meshing, the direction of rotation of driver and driven is opposite. Driver is rotating in clockwise and driven is rotating in anti-clockwise direction. But in case of internal meshing, see over here, because of A, B is rotating, this is external meshing. Because of B, C is rotating. But the relationship meshing between B and C is what? It is internal meshing. And C, because of internal meshing, green is also rotating in anti-clockwise direction, blue is also rotating in anti-clockwise direction. So in case of internal meshing, the direction of rotation of the gears is same. In case of external meshing, the direction of rotation of the gears is reversed. Once again I will repeat. In case of external meshing, the direction of rotation of gears is reversed. If one is clockwise, other will be anti-clockwise. And in case of internal meshing, the direction of rotation of gears is same. See, here also anti-clockwise, here also anti-clockwise. So these were the three things that I wanted you to understand. First is what is a module. Module is a measure of how much the gear teeth are close to each other. Smaller the module, the closer the gear teeth are to each other. Bigger the module, farther away they are. The formula is module is pitch circle diameter divided by number of teeth. What is velocity ratio? See, velocity ratio is velocity of the driven gear or driven shaft divided by velocity of the driver gear or the driver shaft. And velocity ratio has this big formula. Velocity of driven divided by velocity of driver is diameter of driver divided by diameter of driven. And using our D is equal to MT formula, PCD is equal to module into number of teeth, we get diameter of driver is equal to number of teeth on driver and diameter of driven is equal to number of teeth on driven. So, and this is the meshing. In case of external meshing, direction of rotation of the two gears is opposite. In case of internal meshing, Direction of rotation of two gears is C. From the next video onwards, we will start sums on gear trains.